Hey guys, it's Mr. Dugal, and today we're going to talk about scale factor, and we're going to go a little more in depth. At this point, we've talked about scale factor being the multiplier between two shapes. For example, if I have a triangle here, that is a perfect right triangle, it's 3, 4, 5, and I have a multiplier or a scale factor of 1.5. Then each side length is multiplied by 1.5, which would make this 4.5, this 6, and this 7.5. So that is what we're doing with scale factor. Because they're the same shape but different sizes, they are similar shapes / similar figures. The aim of today is to address the biggest misconceptions or the biggest mistakes with scale factors. So the two biggest mistakes that are made with scale factors is one, if the scale factor is less than 1, a lot of times students divide. What I want us to remember is that scale factor is always a multiplier. The reason that's important is because if we divide by a number less than 1, it actually still enlarges our figure. So an example of this would be if the scale factor is 2/5. What I see students do a lot is they'll have a figure over here and one here, and the scale factor is 2/5. So because it's less than 1, the number should be getting smaller, but I see students thinking that they need to divide. So they'll do 15 divided by 2/5. After they keep change and flip, they end up with 15 over 1 times 5 over 2, which gives them 75 halves, or 37.5. Instead of the figure being smaller than the original, we should remember that another cue that this is a mistake, is that our side length is getting bigger. If we did the same thing with the other side, it'd end up being 5 over 1 times 5 over 2 would be 25 halves. A lot of times I'll get papers that look like this, and they'll say 37.5 and 12.5. What this is in effect doing is actually making the scale factor 5 halves, or 2.5, instead of 2/5. So that's the mistake way. If we clear this, what we should have is in fact just multiplying by 2/5. We multiply by 2/5, our numbers go down. Actually, I chose numbers that make it nice and easy to cancel too. We multiply, we get a side length of 6 and a side length of 2, and that is the correct answer. So the first thing to look out for is if the scale factor is less than 1, students a lot of time divide. And what we need to remember is that scale factor is always a multiplier. Okay, that's the first common misconception. The second mistake I see a lot of students make is that they multiply one side by scale factor and divide the other. Or maybe they go forward the first time from the original to the new image, and then they go backwards the other way and go from the new image to the original. So let me show you what I mean with this. So I have a rectangle, and they'll say the scale factor is 3. I'll see it where a lot of students have something like this. Obviously the images I chose here, it's not crazy hard math with the numbers. So we end up saying that if the scale factor is 3, this has to be 15. They went from the original to the new. But on the way back, for some reason, instead of going from the original to the new, this time they go the other way and say, well, what times 3 equals 15? And they get 5 for this side length. On this problem, they end up actually flipping them exactly. So that's not right. We need to remember to always go from the original to the new. From the original to the new. So in fact, this isn't 5, it's 15 times 3. This is 45. Those are the biggest two things to look out for, is just making sure that if you multiply one side from original to new, that you need to also multiply the other side from original to new. The other one is, if the scale factor is less than 1, don't divide. Scale factor is always a multiplier. Remember that multiplication has a reducing effect if we're multiplying by a number less than 1. That's about it. Hopefully these tips are helpful.